danger. IntelliRupter PulseCloser fault interrupters operate at high voltage. Failure to observe these precautions will result in serious personal injury or death. Some of these precautions may differ from your company's operating procedures and rules. Where a discrepancy exists, follow your company's operating procedures and rules. This video series covers protection and communication setup of an IntelliRupter PulseCloser fault interrupter by using IntelliLink setup software. Before beginning, read and understand the overview section of the written instructions. You will need to be familiar with the unique features and functions of an IntelliRupter PulseCloser fault interrupter before continuing. In this video, we'll configure the IntelliRupter fault interrupter for loop restoration. Loop restoration consists of two sources tied together using a normally open tie-point device. There can be any number of closed devices between the normally opened tie point and the energy sources. In this example, we are only showing one device between the sources and the tie point. The settings can be found on the Setup Restoration page of the IntelliLink setup software. Before starting configuration, decide whether this device will be the usually open tie point or one of the midline devices between the source and tie point. In this first example, we will configure the normally closed loop restoration device. Once that decision is made, configure the appropriate general protection profiles as seen in previous videos. To properly configure loop restoration, the following general settings must be set. On the Setup, General, Site-Related page, under Operation, change the mode of operation to Loop. Apply this change to have it take effect. On the operation screen, new Loop Restoration information appears. Next, navigate to the Testing After Initial Trip tab of the General Protection Profiles that will be used with loop restoration. The setting Retain Source Side for Test Sequence is for loop restoration. It will ensure we do not test into the substation source. S&C does not recommend for use in any other application. It should only be used once the proper system analysis has been done to ensure backfeed will not falsely trigger this feature. The purpose of this feature is to make sure that testing occurs only when the appropriate source is returned on a loop restoration device. If there is a need to only have it test when the source originally feeding a fault is available and not the other source, then this option should be enabled. When the device trips and this setting is set, it will only resume testing when the source feeding the fault has returned. We will leave it turned off in this example. Once the general profile settings have been configured, navigate to Setup, Loop Restoration. First, we will choose which profile has been designated to operate for loop and enable it. In this case, General Profile 1. Once enabled, choose the direction. The device can operate in one or both directions. In this example, we only want testing to be done on the load side or direction 2, and we do not want this device testing for faults on its source side. So we will enable testing only for direction 2, the load side, for this device. For normal state, we will select Closed because it is a normally closed device. The setting Protection can be set as voltage trip or sectionalizing trip. In this case, we will select Voltage Trip. Next, navigate down the page to the Loop Restoration Test Sequence section. Loop restoration uses an independent test sequence that is different from the test sequence used if the device is tripped on a fault. In this case, when the device has lost voltage and tripped on the voltage trip function, it will use the loop restoration test sequence. Tests can be added or removed with these buttons. This example will have 3 tests. The closing profile can be chosen from the Close option drop-down menu. Each test sequence after the first test has a delay time in seconds. As the number of tests increases, the minimum delay for each test will increase. Closing profiles can also be changed independently for each test. This enables configuring the typical profile for the pulse-finding fault location technique, but allows one profile to use a point-on wave close in case a fuse needs to operate downstream. Other considerations in the configuration will be whether you want loop restoration to be enabled automatically under different circumstances, including manual lever operations or hotline tag removal. In this example, the IntelliRupter fault interrupter is normally closed. When Automatic Enable of Loop Restoration for Manual Lever Close is checked, the device will automatically go into loop restoration mode when the manual lever is closed and if all other conditions are met. The time delay before first test is the amount of time that will pass between voltage loss and the first test. The next setting is max time allowed for restoration. Once a loop event begins, this is the amount of time the device will be allowed to respond. When this timer expires, loop restoration will be disabled and no further testing will occur. This is to ensure there is a predictable window of operation for the loop restoration feature to avoid unexpected operations when field crews arrive. The recommended setting is based on your company's operational practices. It should be set long enough that loop restoration can occur, but short enough that loop restoration will be disabled when crews arrive on site. The setting Reset Max Restoration Timer based on multiple contingencies is only used for normally open devices, which we will configure now. We will configure Profile 2 as a normally open tie point device. In most applications, this device should be set to operate in both directions. The normal state will be set as open. This creates a new option, Good Frequency to Close. This feature will prevent closing when an under-frequency event occurs before the loss of voltage. There are more settings in the general profile to support this feature. Navigate to the Profile 2 Voltage, Frequency, and Sectionalizing page. The Frequency Trip section, and to the Low Frequency Indication section. Set the Under Frequency Enable in that section to Yes. This will enable the under frequency set of controls. With Good Frequency to Close set to Yes, if the frequency drops below the under frequency threshold for the under frequency time to detect, then closing or testing of the device will be blocked, preventing it from restoring service and potentially increasing load on the circuit. For the normally open device, the test configuration works the same as the closed device. Tests can be added or removed to match the testing requirements. In this case, we will select Automatic Enable of Loop Restoration for Manual Lever Open because we have a normally open device. Automatic Enable of Loop Restoration for Hotline Tag Removal can also be checked in this case. Once again, apply settings. Once the device detects loss of source from one side or the other but retains good voltage from the opposite side, the Time Delay Before First Test timer will start. At the expiration of this timer, the normally open tie point will begin testing. This timer should be long enough to ensure any downstream devices that may be responding to a fault have had adequate time to run through their test sequence and lock out. It also needs to be long enough to ensure the voltage elements on the normally closed devices also have time to respond properly. Max time allowed for restoration works the same way with a normally open device as with a normally closed device. However, S&C recommends taking extreme caution when using the Reset Max Restoration Timer based on multiple contingencies. There are a number of considerations that should be studied carefully in S&C Instruction Sheet 766-530 on the use of this setting. It is intended to provide additional opportunity to restore service on circuits that have a high number of contingency events occurring on them where the normally open device may see loss of voltage on both sides and then a return of voltage on one side or the other. The caution with this feature is that it extends the predictable operational time of the loop restoration feature and effectively puts a degree of uncertainty around the time the loop restoration feature may be active. Always make sure it will not cause unexpected operations when service personnel are on site servicing the device. Once configuration of loop restoration is completed, navigate to the Operations screen. There is a Loop Restoration Enable-Disable function now, along with additional indicators to help understand the settings of the feature. When loop restoration is active and timing, the timer will be seen in the second box. If the indicators show that loop restoration is ready and the timer is timing, make sure there is no crew on site at the device, as it may operate. If you have a normally open device that closes due to a loop restoration, or a normally closed device that opens due to a loop restoration, the reconfigured indication will be active. The text will be red to indicate it is an active function. Otherwise, the text is gray. For complete details on loop restoration settings and their functions, refer to S&C Instruction Sheet 766-530. We hope you have found this video informative. If you have any questions, visit our website at snc.com.